Welcome to the deep dive. Today, we're tackling something really interesting on the horizon. A fundamentally new way to think about desktop automation. It's called UFO2, the Desktop AgentOS.
Exactly. Yeah, we've had these computer-using agents, CUAs, for a while now, promising, to automate stuff on our desktops.
Right.
But honestly, they've often hit some pretty big walls. A lot of the current ways agents try to automate things, well, they don't really get the operating system underneath.
We don't have that deep connection.
Not really. It's kind of like trying to build, a really complex machine using only basic building blocks. You can make cool things, sure, but you're always limited.
Okay, so let's unpack that. What are those limitations? What does that actually mean for, someone trying to use these things?
Well, a big part of it is they mainly rely on just looking at the screen, like interpreting screenshots and mimicking basic mouse moves and keyboard taps.
So visual input mostly.
Mostly visual, yeah. And that can be super inefficient, kind of noisy, and frankly prone to errors. Think about it if a button shifts just a little bit after an update.
The whole thing breaks.
Pretty much. The visually based agent just gets lost. And they rarely use the richer info available through things like OS accessibility tools or application APIs.
So there's deeper information available, but they're not tapping into it.
Exactly. It's like having a translator who only knows one dialect trying to follow a conversation in several. They're missing a lot of the nuance and structure.
They're locked out, essentially.
Pretty much. And maybe the most annoying thing for the user. Because these agents are literally moving your mouse cursor and typing on your keyboard.
You can't use your computer while it's running.
Right. It completely takes over, which isn't great if you need to do something else quickly or just, multitask. How often have you had to just sit there and watch it?
Definitely been there. Okay, so that sets the stage for UFO2. What's the big idea here? What's a fundamental change they're proposing?
The core idea, really, is to build support for this kind of automation directly into the operating system.
Into the OS itself.
Yeah. Think about it. Our operating systems manage everything, right? All the complexity. But they don't really have a standard, robust way for an agent, an AI, to programmatically control graphical applications.
That's a gap.
It is. And UFO2 is trying to provide that missing layer, a set of what they call first-class abstractions specifically designed for automation, moving beyond these sort of tacked-on surface-level fixes.
Okay, so not just an app you install, but something more fundamental, integrated.
Exactly. And the way they do this is through a really interesting architecture. It's built around a centralized multi-agent runtime.
Multi-agent.
Yeah.
Okay, sounds potentially complicated. How does that work in practice?
Well, you've got a central hostage. And think of it as the controller, the orchestrator.
The conductor.
The conductor, yeah, good analogy. It breaks down the main task, handles errors if something goes sideways, manages the whole automation lifecycle. It uses a pretty straightforward finite state controller-like steps: continue, assign, pending, finish, fail to keep things on track.
And how does this hostage actually see or understand what's happening on the desktop?
It uses two main things. There's a visual layer, screenshots, like we talked about, for a general overview. But crucially, there's also a semantic layer.
Semantic layer.
Yeah, it taps into Windows UIA APIs. That's the User Interface Automation Framework. Think of it like a hidden language the applications use to talk to the OS, describing every button, menu, text box in detail.
So it's not just seeing pixels that look like a button.
It knows it's a button. Yeah. It knows its name, its state, whether it's enabled. Much deeper understanding than just a picture.
Got it. That makes sense.
And then working with the hostage, you have multiple epigents. Yeah, these are like specialists. Each one is designed to understand a specific application really well. They're kind of loosely coupled, but they have deep app-specific knowledge.
So like an expert for Outlook, another for Excel, that sort of thing.
Exactly. One for your email, one for your spreadsheet, maybe one for your web browser.
And these agents, they also perceive things differently.
They do. They combine that visual input with the semantic info from the UIA APIs, and they even use something called symbolic annotation with set of mark. It's like putting virtual sticky notes on controls saying, this is the submit button, or enter the date here.
Adding extra labels.
Right. And then they output structured information. What control to interact with, what action to take, click type, etc., any arguments needed, their reasoning for doing it, and their own internal state. They also have their own little finite state machine.
Okay, so you have the main conductor, the hostage, and these specialized players, the agents. How do they all work together on a task that spans multiple apps? Like copying data from a spreadsheet into a web form.
They communicate and coordinate through a shared space called a global blackboard.
A blackboard, like a shared whiteboard.
Kind of, yeah. It's where they can post intermediate results, flag when one agent needs something from another, share status updates. It allows for these complex workflows across different programs without needing rigid, predefined scripts for every single step.
That sounds much more flexible, much more dynamic. Now, you also mentioned something about a virtualized environment. What's that about?
Yes. This is really one of the standout features, I think. It tackles the user experience and safety head-on. UFO2 runs all this automation inside a virtualized picture-in-picture desktop, a PyP window.
Picture-in-picture, so like a little window on my screen showing a whole separate desktop.
Exactly that. It's a fully functional replica of your normal desktop running inside this resizable, movable window. It uses Windows RDP loopback technology, basically creating a separate, isolated session running right there on your machine.
Okay, hold on. So the automation isn't happening on my main desktop that I'm looking at.
Nope. It's happening inside that PyP window. And this is huge.
Why? What are the benefits?
Well, first, it means the automation can just run in the background without messing with what you're doing on your main desktop. You can keep working, browsing, whatever, while the agent does its thing in its own little world.
Oh, wow. That completely solves the disruption problem we talked about earlier. No more waiting for the agent to finish.
Exactly. Huge productivity win right there. And second, safety.
How so?
Because it's a totally separate session, the inputs and the application states are isolated. What the agent does in the PyP window cannot accidentally click something or mess up an application on your main desktop.
And vice versa. My clicks don't interfere with the agent.
Correct. It provides really robust isolation. It's just a much safer way to run potentially complex automation. Plus, they use secure channels, something called named pipes, for communication between the agent and the PyP and a coordinator on the host side. So it's contained, but still coordinated.
That PyP idea sounds incredibly practical. Really addresses those core user frustrations.
Okay, now UFO2 also seems pretty big on learning, right? Continuous knowledge integration.
Yes, this is another really fascinating part. It's not just static, it's designed to get smarter over time. It maintains this persistent, constantly growing knowledge base about the applications it interacts with.
How does it build that knowledge? Where does it come from?
Two main ways. First, it can actually learn from documentation. You can point it at user manuals, help files, guides for an application.
Really? It reads the manual?
It parses it, yeah. It extracts structured information like, here's how you perform this task, these are the steps, and stores it in a vector database. So later, when an agent faces a tricky situation, it can query this database for guidance.
So it's like having the official instructions on hand, instantly searchable by the AI.
Exactly. It helps it handle less common tasks or variations much better. The second way it learns is from its own success.
Learning from experience. Right. It keeps detailed logs of successful automations. Then a summarization module processes these logs and creates reusable example records, basically. Here's a task I did, and here's the successful plan I used.
So it remembers what worked.
And it uses that. When it sees a similar task again, it can use that past successful example through in-context learning to inform its plan this time around. It helps it get more efficient and reliable.
So it's not just learning from manuals, but building its own sort of best practices library based on what actually succeeds in the real world.
You got it. It's kind of like retrieval augmented generation, RESHA, but applied at the OS automation level. It's constantly retrieving relevant info from docs and past runs to guide its current actions.
That continuous learning loop sounds powerful. Again, another term that jumped out was speculative multi-action execution. Sounds fast.
It is. It's designed purely for efficiency. It's inspired by like how modern CPUs work with speculative execution. Instead of asking the language model for just the next single step,
It asks for several steps.
It asks for a batch of likely next steps. It predicts, say, the next 3 or 4 actions needed for the current subtask all in one go.
Okay, but what if the situation changes before it gets to step 3? What if the prediction is wrong?
That's the clever bit. It doesn't just blindly execute them. It validates each predicted action right before executing it using those UI APIs again. It checks. Is the button still there? Is it enabled? Is it visible right now?
So it predicts ahead, but checks reality at each step.
Exactly. It executes the predicted steps sequentially. If any step fails validation, maybe the UI changed, the button disappeared, it immediately stops that sequence and asks the model to replan based on the current real state.
I see. So it speeds things up by reducing the number of calls to the LLM, but without sacrificing accuracy because of the runtime validation.
Precisely. It finds a really nice balance between speed and robustness.
Makes sense. Now, doing all this complex stuff automatically, what about safety? How does it prevent the agent from, doing something dangerous accidentally, deleting files, closing critical apps?
Yeah, super important. UFO2 has a dedicated safeguard mechanism built in. It actively monitors the actions the agents propose.
How does it know it's dangerous?
Based on predefined risk criteria. These can be customized, but typical examples would be actions like deleting files, terminating processes, maybe changing system settings. If an agent tries to do something flagged as risky,
It stops.
it transitions to that pending state we mentioned earlier. It pauses the automation and requires explicit confirmation from you, the user, before it proceeds with the risky action.
So it asks for permission first. Are you sure you want me to delete this?
Essentially, yes. It puts a human in the loop for potentially irreversible actions. And again, what counts as risky can be configured, which is important for different environments.
That's a crucial safety net. Okay, what about new applications? The software world changes constantly. Is UFO2 limited to apps it already knows?
No, it's designed to be extensible. They have this concept of an agent registry.
A registry?
Yeah, it allows third-party developers or even internal IT teams to create their own APIs for specialized software, maybe domain-specific tools or proprietary internal apps. They can wrap these components to fit the UFO2 agent interface and plug them into the system.
So it can grow into a platform, people can add support for more and more tools.
That's the idea. Make it an ecosystem. And to help manage all this, especially in larger deployments, they've structured it as AgentOS as a service.
Client server model.
Right. You have a lightweight client on the user's machine doing the GUI stuff, handling the PyP window. But the heavy lift, the hostage logic, the agent processing, the expensive LLM calls happens on a centralized server.
Okay. That makes sense for scalability, maintenance, keeping things updated, security probably too.
Definitely.
Right.
And for anyone needing to figure out why an automation did what it did or if something went wrong.
Debugging. Logging.
Yep. Very comprehensive logging. It captures detailed, traces the prompts, the LLM responses, all the UI metadata it saw, agent states, any errors. It compiles all this into a markdown file for each session.
Markdown. So it's readable.
Very readable. You can inspect it, visualize the flow, even potentially use it to replay the session to figure out exactly what happened. Really valuable for developers and troubleshooters.
That level of transparency is key. And how do they actually measure if UFO2 is any good? How do they evaluate its performance?
They built an automated task evaluator. It actually uses an LLM acting as a judge.
An AI judging another AI.
Kinda, yeah. It analyzes those detailed logs, the actions, the agent's reasoning, screenshots, and uses chain-of-thought reasoning to assess if the original task was completed successfully.
How does it judge?
It breaks the task down into criteria and gives a structured result: success, partial success, or failure. It provides objective feedback for measuring progress and comparing UFO2 to other methods.
So a built-in way to track improvement. Very neat. Okay, the big question then, how did it actually do in testing?
The results look pretty promising, actually. They tested it on benchmarks like WAA and Oswald W across, I think, over 20 different Windows apps. UFO2 showed significantly higher task completion rates compared to other leading CUAs, like Operator.
Higher success rates. What specifically made the difference?
The paper points to a few things. That hybrid approach using both visual cues and the deeper semantic APIs was key. Also, better visual grounding, understanding what's actually on the screen, and that continuous knowledge integration really helped.
Learning from docs and experience paid off.
It seems so. They also looked at the failures, of course. Challenges remain, especially with detecting controls in really unusual or non-standard interfaces. And sometimes planning errors crop up in very complex multi-app tasks, areas for future work.
Makes sense. And those specific features using app-specific APIs when available, the learning, the speculative execution, did those show clear benefits in the numbers?
Yes, absolutely. Integrating specific APIs boosted success rates quite a bit and often reduced the number of steps needed. The continuous knowledge integration demonstrably cut down on planning failures and speculative execution. It kept the success rate high, but significantly cut down the average number of steps and the overall time taken. Big efficiency gain there.
Wow. It really sounds like UFO2 is taking a significant step beyond current approaches. Now, it's focused on Windows now, but what about Mac or Linux? any potential there?
The researchers seem optimistic. Because the design is modular and relies on those underlying OS accessibility frameworks, which equivalents exist for macOS and Linux, they believe the core ideas could be adapted.
So the multi-agent architecture, the OS-level abstractions, those concepts aren't Windows-specific.
Not fundamentally, no. It suggests a path towards maybe a more unified, intelligent automation approach across different operating systems down the line.
Okay, so let's recap. UFO2 is really trying to solve the brittleness and disruption of current desktop automation by going deeper, integrating with the OS, using this smart multi-agent system.
Right, with the host agent conductor and specialized app agents.
And bringing in cool innovations like that isolated PyP environment so it doesn't interrupt you. Plus the continuous learning from docs and experience and the faster speculative execution.
All aiming for automation that's more reliable, more efficient, safer, and just less annoying for you, the user.
Yeah, less disruptive seems like a huge win.
Definitely. Moving beyond just mimicking clicks to genuinely understanding and interacting with the digital environment.
It really makes you think, doesn't it? Could this kind of deeply integrated AgentOS, an OS built with AI agents in mind, be where we're heading? Are we moving away from manual clicks and typing towards a future where we just tell our computers what we want and intelligent agents handle the complex workflows seamlessly within the OS?
The compelling vision.
What new kinds of interactions, what new capabilities become possible when AI can truly perceive and act within our digital world at such a fundamental level? That's definitely something to chew on. Thanks for diving into UFO2 with me today.